Okay, so MATLAB, um, let's go back a little bit. So we look at putting MATLAB into context. We will look at what a weakly typed language is, understand the different data types in MATLAB. We will discuss similarities and differences between data types in C++ and MATLAB. And we went through some of these last time, so I'm not going to spend a lot of time. But again, this is the chart that shows, this is an IEEE spectrum chart, which is basically like annual ranking based on, they do a survey of what people used in the past year, how many lines of code and how many programs people wrote across the globe in different languages. So based on that, they come up with these and they find that Python is number 1, and relative to that, Java is number 2, C and C++, 3 and 4, but I would, imagine that they're pretty similar. So if you were to club them together, they might, be ranked 1 or 2. And R has become pretty popular. It's an open source language used for statistics and such. But then coming to number 8 is MATLAB. It's still pretty popular, and it's a desktop or computer-based language. You don't have web versions or smartphone versions and such. And this is the topmost proprietary language out there in this list. So all the other ones are freely available. You don't need to pay to use them. But MATLAB, you do need to pay to use MATLAB. Okay, so the other versions, as I said, are they are not proprietary. You can just pick them up and start using them. There are free interfaces available officially by the creators, but MATLAB is a paid. You have to get a license to start using it. So MATLAB is a contraption of words from like matrix laboratory. It's working with large arrays of values is pretty fundamental concept behind MATLAB, and we're going to use that to do that capability of MATLAB. It was originally released in 1984, and MATLAB itself is written in C and C++ and Java, and some parts of MATLAB are written also in MATLAB itself. And the variables are weakly typed, and we will discuss what that is. It's often used as a scripting language, meaning that you don't need to write the whole piece of code to start processing it. You don't need to compile the whole code. You can just write a sentence or just a small command or two and then process it immediately. Okay, so this is a big Hummer SUV limo here. So if you remember when we were talking about C++, I gave an example of a race car. And for discussing C++, in a race car, you only add things as needed. You'll add a seat belt, you'll add an engine if you need it, but it comes pretty bare. You add bare minimum things. So that's C++. On the other hand, MATLAB is like a Hummer SUV limo. It comes with everything, all the functions, all sorts of stuff with it. You name it, you've got that capability. It's all the fancy stuff. It has lots of toolboxes, a lot of built-in functions, and a lot of things which are ready to go. But then this also makes it not very efficient and a little bit slower with compared to other C++ and other languages like that. But then it can do a lot of fancy things pretty quickly, get you up to speed with a lot of things that you want to do computationally pretty quickly. Has a lot of built-in stuff which comes in pretty handy. So it's got all bells and whistles, even though you may or may not need it. Remember in C++, we have to hash include libraries or header files when we have to start, or a CMath library when we have to start using certain types of functions and such. In MATLAB, it's already all there, so you never need to include stuff. It's like you use a tool to do a lot of different things, which has multiple different ways it can function, and so you have like a multi-purpose tool with you, which can pull out a screw, which can hammer, which can do multiple functions. But of course, you need to be careful It can do most things, but it cannot do everything. And sometimes if you don't realize its limitations, you may end up with something not working properly. Okay, comparison with MATLAB and Excel. They are kind of similar in the sense they're both proprietary. You need to buy MATLAB and Excel. They're both give you like a tabular view of things, a lot of data you can see in Excel and work on it visually. But Excel starts running into problems or starts reaching its limits when you have hundreds or thousands of data points or rows and columns. Basically, Excel was designed to work with data that you can see. But when you have data that you cannot see, like your hundreds and thousands of data points, which you potentially cannot see or care about, then not only does it not serve the purpose of Excel, it may even cause Excel to crash when you open it. I have experienced myself personally working with a data set which had 200,000 rows and about 20 to 40 columns in the data set. And I had a hard time keeping my computer from crashing whenever I opened that file. So MATLAB has its limitation, and Excel has its limitation, and that's where MATLAB comes into use. It will show you only what you need, and you can just write commands and do stuff, and so that's pretty handy in that sense. And they both, Excel and MATLAB, both have a GUI, graphic user interface, which makes it accessible to more people. And we look at the MATLAB interface more, but this is basically, you have a workspace which has your variables defined. You can see the variable A, variable B, and this is the command window. So I defined a variable A to be a 1D array of which had two values, 1 and 2, and then you can type A equals what, and it'll give you value of A, and then B, and so forth. So that's the command window, that's the command history. So now MATLAB features, as I said, MATLAB has thousands of built-in functions in the base software, and thousands more additional toolboxes. It has a statistics toolbox, there's a robotics toolbox, it has a control toolbox, image processing, Arduino toolbox, and whatnot. And there's a MATLAB central community, which is like a forum for posting your questions and getting other MATLAB users to, maybe help troubleshoot your code or give other suggestions of what you're trying to do. So it's a pretty thriving and busy community where you can get a lot of answers or pointers to what you're looking for. And even apart from the MATLAB Central, even this MATLAB itself has help. Like if you have MATLAB, in the command line you write help, and and then write whatever MATLAB keyword or MATLAB topic. You just write that and it'll pull up the resources for where to go. And as I said, UF has a site license and it can be downloaded for personal use at uf.edu/OIT. GNU Octave, it's GNU Octave is a free alternative to MATLAB. Its base is nearly identical to MATLAB base, but many toolboxes are different. However, we won't use those toolboxes in this course. And in fact, we won't probably use any toolbox in this course. We're just getting a fundamental idea of MATLAB. Once you get that, you can get it and start going. A lot of help available, as I said, MATLAB. I self-taught MATLAB a few years, about 10 years back, I was doing a problem which needed to use MATLAB and my Excel was crashing. So I turned to MATLAB. I self-taught myself in a couple of weeks and then started working with it. It was pretty easy to get up and start working on, more than C++. If I had to do C++ like that, I wouldn't have been able to do that. I learned C++ back in school with an instructor and such, but then yes, MATLAB is, once you have a little bit idea of programming and coding, there are a lot of ways you can learn MATLAB. In fact, I would also suggest, and maybe I'll post some links on Blackboard as well, there are lots and lots of videos and tutorials on MATLAB out there on YouTube, on different sources you can find to learn MATLAB. And maybe it may not be a bad idea to go through some of them to get up to speed with some things. This video keeps shutting down. Okay. And as I said, Octave is about 99% similar to MATLAB, and Octave Online is similar to an online compiler in C++. So moving on to weakly typed. So best way to define that is to first define what's a strongly typed. A strongly typed language require an explicit definition of data type. So we have these, for example, C++, we define int, var1, double, vec2. So we are specifying what my variable type is right up front. And that we need to do in C++. But weakly typed languages implicitly convert between data types when possible. And you don't even need to define something. For example, this, if I say vec2 equals 5, var1 equals vec2, and don't worry about these angular brackets. They are just prompts in Matlab. They appear automatically. They appear automatically, and this is what we are typing. We are typing vec2 equals 5, var1 equals vec2. So, and automatically Matlab will give them a variable type of double, float double. So Matlab defaults to 8-byte, that's 64-bit floating point value called double, effectively declaring as double the first time it is used. So 64-bit is a pretty good space to hold your, computationally hold your data. Now different data types, we have double, it converts to double precision, single converts to single precision, int 8 converts to 8-bit. Now 8-bit is 1 byte. So remember the double is 64-bit. So int 8 will convert something to 8-bit signed integer. Int 16 will convert to 16-bit signed integer. 32-bit will convert to 32-bit. 64 will convert to 64-bit signed integer. When it's signed, it's from minus to plus. And when it's unsigned, it's only take positive values. So if you have like let's say the 8-bit will have a maximum value of 2 to the power 8. So that will be to 64, 256. So the 8-bit will have 2 power 256. So if you have unsigned 8-bit, it will go from 0 to 256. If you have a signed 8-bit, it will go from minus 128 to plus 128. So let's see this example here. If I have a value val equals 500, so it will default to double, but then I didn't define anything. As I said in the beginning, in Matlab, we don't need to define stuff. It will automatically take in double, default to double precision, which is 64-bit. But then I'm converting with this command. You can write any data type and convert that using this. So this says unsigned int 8, 500. Now remember, unsigned it can only take from 0 to 255. It cannot take 500. So what it does, Matlab clips it to the maximum value. Now in case of C++, it works slightly differently. It doesn't clip to the exact value. It clips it slightly under. Like your odometer, when you push on the brakes, it can not just stop there. It'll go a little bit down. So the behavior is different from C++. Matlab clips at the maximum value. And with C++, it would roll over like an odometer. So for example, it might be 244 in C++ instead of 255. So other integer data types. So I said signed 8-bit integer would go from minus 128 to 127. Signed 16-bit would go from minus 32,768 to plus 32,768. Signed 32-bit would go to a larger number. And this is the Matlab command here, int 8, int 16, int 32. Unsigned would go to even larger. So that's, that's the double for integer, what is a 64-bit. And similarly, unsigned would go from 0 to 255 and so forth. So if I have my variable equals, I define it as a unsigned integer 64, that would be valid. Okay, quiz question. What value results from val equals unsigned int 8 for 400? So we just discussed it. It shows this, it's the same, it's a value of D, 255. Okay, next question. So there's a next question now. What value results from unsigned it in 16, 400? So in this case, you're right. It'll, because unsigned integer with 16 bits, it can take larger values and it will be 400. Okay. So predefined constants. So Matlab has a few constants already defined, sort of like we use hash include CMath that did it for us in C++. However, here we don't need to include anything. Everything is already included. So we will have all those available to us as we start Matlab anytime. So this is pi. Pi is 3.14. I and j are also included keywords or predefined keywords in Matlab. And what are I and j? Any guesses? So I and j are the complex numbers, which is the square root of -1. So you might have studied that. We define complex numbers as I, and sometimes it's defined as j in electronics, especially because the electrical engineers define I as current, so they don't want to confuse it, so they use j. And so they're both defined as square root of -1. INF is infinity, NaN is not a number. So those are all predefined things in Matlab. And then, so you could do sine of, say, pi by 4. So it automatically assumes, unless you decide it not to, that we are doing things in radians. So sine pi by 4, what is that? Sine pi by 4 is sine 45 degrees, which is 1 over root 2, which is 0.707. Now sine of pi is 180 degrees is 0. So this is not showing me 0 exactly, but it's showing me as close to 0 as it can get. Now, if I say I, what is I? Then it says it's 0 plus 1i, which is like a complex number. And when I say I star I, it gives me -1. And what's j? J is same as I. And you notice that whenever you like prompt, so Matlab can be also used as a calculator. You have this prompt here, whatever you type, it'll give you the answer. And so like here, you notice that everything you type is automatically stored in a temporary variable called ANS as answer. Similar to like what happens in a calculator sometimes. Okay. See. Now EPS is epsilon, it's a constant. And epsilon is the smallest change in a floating point value that can be represented. So now this is something it's good to know. It won't impact a lot of your programming in Matlab, but it's good to have that understanding. Effectively, it is the uncertainty in the value due to the computer's inherent rounding. And we studied a little bit about that in C++ as well. The computer rounds things. It doesn't do exact value. So the error that is there in any Matlab computations, that's the least amount of error. And you can even ask Matlab what the error is. For example, if I have a number 1 by 4, what is the epsilon on that? What's the error on that? So Matlab tells me the error on that is this. What's the error on half? The slightly greater error. On 1, more error. For 2, slightly greater error. As you can see, the error is getting multiplied by 2 each time, because as I'm multiplying the numbers by 2, the error is getting multiplied correspondingly by 2. So also you see, so the error if I define something as a single, not a double, for 1 is, that's my error. It's pretty small, but If I define it as double, now the same one, it has a drastically lower error. So, okay. So quiz question. So remember, if something is true, you'll get 1. If it's false, you'll get 0. So I'm getting people saying, some people saying true, some people saying it's false. So this would be, actually this would be true. Because, as I said, the greater the number, as we saw, the larger is the error in general. So the answer would be B, true. Now, characters and strings in Matlab. So there's no clear difference between a character and a string. And we always use single quotes in Matlab, like str equals hello. So not there, Matlab doesn't use double quotes at all. And Matlab uses 2 bytes per character for a wider character set. And you can look at that link. I post the slides as well on Blackboard. So here you see it's str is equal to a. And remember also another thing, just a side note here, is in Matlab, you don't need to put semicolon after each statement, but you still want to put semicolon, say, as soon as I write str equals a, this shows me like my output here. But if you want to suppress the output, then you might want to write a semicolon. Let me show you quickly what I mean. I need to switch screens, so I'll just take a 30-second break here. Okay, so you can see here my MATLAB screen. So these are the prompts, as I said. So if I say, you're gonna wanna look right at the bottom here. So, which it's not showing for some reason. Let's see. Let me do this. So here you see I say A is equal to 2, and it creates immediately a variable A. You can see here's the variable A, value is 2. And but if I say B is equal to 3 and I do a semicolon, it will just leave it right there. It will not give me an output of what it is looking like. So in general, you don't need to. Like if I do str is equal to A, it will immediately show me, you know, if you go, let me see if I can do this. So you see here, this is str is equal to A, and it will immediately show str. Let me write that again. So that is str. But if I write str equals A, it'll suppress the output. See, it didn't give any output. Although it's doing that in the memory. Or if I write str equals B, semicolon. So now if I write what is str, just to write str, it'll show me it's B. Okay, so go back to our slideshow. So here, unsigned int 8 of str. So that'll give me the ASCII value of A, which is small a, which is 97. And I say char 255, that'll give me the other way around, the character corresponding to 255. So if I say str equals hello, then, and I convert that into unsigned integer of 8 bits, that will give me the corresponding ASCII value of each of those characters. Okay, so getting on to next section. Questions on this so far? Okay, no questions so far. So branching in Matlab. So here we will do review if-else logic flow in Matlab syntax. We will review logical operators, review the switch statement in Matlab syntax, and review the while loop, review the for loop and array indexing, and discuss something called sprintf syntax, which you might need in your homework. Okay, so the if-else syntax in Matlab, it is, so I have the if statement. If A is equal to 2, if that is correct, then display. That's the way of doing cout in Matlab. Display A is 2, else display A is not 2, and then end. So notice there are no curly brackets here. So we use curly brackets. So there is no like, you know, we don't have these things here. So we don't need those. So I can say if A is equal to 2, then display A is 2 and end. So what's happening here, if you notice that if A is equal to 2, then display this, else do this, and end will tell me that my if else has ended. So you need both, all the three, if, else, end. Or you definitely need the end, but you don't need the else statement. So that's what it's showing here. So if A is equal to 2, display A is 2, and then end, and then display the rest. So you don't necessarily need the else statement, but you do need the end. So here it's showing the logical flow of things here. In this case, in the first case, If something is true, it goes here, else it goes here. So here in this case, it's going, if something is true, it goes here. Otherwise, it just goes here by default, right? And then it'll turn back here anyway again. Now, something you can use something called else if to give another option. So if A is less than 2, maybe you go here and let's get my, okay, so if A is less than 2, maybe, so you maybe go here. And if not, then you do another question, else if A is greater than 2, maybe you go here. Else, if none of them satisfies, you go here. And then you end. So you still need an end. Now notice one thing, that else if is itself a keyword. And there are no spaces here. So there's no space between E and I. Because you can put a space, but that becomes a different sort of a thing. And that is correct. But I'll just mention in a moment what that is. So you have if, else, end. And another thing to notice here is Matlab, when you work in Matlab, it automatically gives your keywords in a separate color. So you notice this sort of a bluish tinge here to this if, else, and so it's coloring those keywords slightly differently to you to recognize that it's a keyword. Now, if you have this A less than 2, display A is lesser, if else, if, now notice there's a space here, which won't give me an error, which is okay. But now what it's doing is, it is going into this whole separate if loop here. Okay, so if A is not less than 2, then you go to this whole another loop, and this loop is if else end. But now when it does this if, this else, it does not find an end here. You need to write another end now. If you don't find an end here, it'll give me an error, right? In this case, you did not need another end because it's just all one loop. But here, that's a logical flow of this sort of else if. So maybe you are going to be a little bit careful to maybe not use this one here, but probably use this one here. Questions? Okay, no questions. So yeah, not use this one here, but to use that one. Logical operators. So some logical operators are similar to C++, like our greater than, less than, greater than equal to, less than equal to, equal to. And the different are the AND operator. So anybody remembers what is the difference here? How did we use the AND operator in C++? Yes, C++ had a double ampersand. So in C++, we would do and. So here we only use it once. We don't use it, write it twice. So this is called ampersand. And this ampersand, in C++, we would do twice. And similarly in C++, the OR would be twice. And this here is not equal to. In C++, what was this? Anybody? How did we write not equal to in C++? Yep. So that's how we write not equal to in C++. But here we use a tilde sign. It's called a tilde sign. And then not is again just this tilde here, small wave-like sign. So when I write not, it's a Boolean or a logical operation. So not 1 is 0, not 0 is 1. Now not 2 is again false. So anything except 0 is true. So not 2 would be 0. And precedence. So Precedence is parenthesis. We have unary plus, minus, logical negation, multiplication, division, addition, subtraction, colon operator, less than or equal to, greater than equal to, not equal to, logical and, logical or. So that's sort of the, and there's one more here, I think should be here, is exponent. But otherwise, so this is the unary plus minus. This is not the addition and subtraction. This is like if a number is -1 and so forth. But usually, like, so you can probably sort of ignore it if it confuses you. But parenthesis, exponent, multiplication, division, addition, subtraction. Sometimes it's also called as PEMDAS. Parenthesis, exponent, multiplication, division, addition, subtraction, and after that you have other operators, but then remember the and or are sort of the last ones here. So they come sort of in the end. So this is the unary minus. So A star, 2 star minus 2 would be -4. That's what it meant by unary minus or plus. Now there are bitwise and or requires use of functions bit and bit or. So we in C++ we were using just like, you know, we were using symbols for that. And but here if you want to use bitwise, meaning if you convert that to binary bits and then compare, then that's what you get. So that's 9, that's 3. So for the or, you will have 1, 0, 1, 1. And this would be equal to 2 to the power 3 plus 2 to the power 1 plus 2 to the power 0, which will be equal to 8 plus 2 plus 1 will be equal to 11. Right, so that's how you get this 11. Questions at this point? Okay, so let's do a quiz problem. So what would be the answer? D, E, B, B. So the correct answer to this one is B. Now, let me just ask, I think Finn was the first one to say B. So maybe let's ask Finn to explain. Maybe Finn, can you unmute yourself and explain why it's B?
It's, let's see. To be quite honest, I kind of guessed.
That's a guess. Okay.
Yeah.
Let's see, Joran, or I don't know how you, if I'm saying your name correct or not, but do you want to explain, or was it a guess too?
I'm in the same boat.
Okay. Now that I said it, does anyone want to? Okay, let me go ahead with this one. I can explain it here. So the logical precedence, this would be evaluated, the OR would be evaluated last. And regardless of what result of this is, since this is always true, right? This one is always true, then one of the two has to be true to get the answer as true. So this will be always true. Make sense?
Why is OR 5 always true?
Why is OR 5 always true? Anybody wants to answer that?
Because 5 will never be anything other than 5.
Right. So that is, thanks, Simon. That was Simon, right?
It's Kinnan.
Kinnan, sorry. Okay, and why is that 5 always true? So when we evaluate true and false, any number other than 0 is true. Any number, and 0 is always false. So if you remember, let's go back to this thing here. So not 2 was 0 because 2 is true. And if you invert the true, not true, it becomes false. And I think we did something like some examples like this even in the C++ section. So if you have a number which is a non-zero number, that becomes true because there are only two options, true or false. That's sort of how it works. Does that make some better sense? Okay. Didn't get a feedback, but probably helps. Okay, let's go forward. And one more question. And what I'm going to do now, I thought of a thing that I'm going to do. Whenever we do these questions, like the multiple choice questions, I'm going to keep a log of like all your names in here with me. And the first persons, so the first person to answer give the right answer with explanation gets a tick mark in my notes. In the end of the course, I'm going to count those tick marks and awards a bonus somehow or the other. I'm not going to, go into detail of how, but you're going to get some amount, some kind of a bonus for that. Okay, Enigma, you have a question. So can you explain on your question? Expand on your question. I didn't understand your question.
So what I mean, sorry if there's background noise. What I mean is, like, when I read this as a person, I think like A less than B or 5, which like makes sense because it's like would evaluate to true if A is less than B or if A is less than 5. Is that what it's saying, or is it just like something else?
I see what you're saying. So yeah, you don't read it like a normal person, I guess. You read it like a computer. And computer, the way computer is doing is, and if you like, the computer reads the precedence, goes by the precedence. So it's not A is less than B or A is less than 5. No, what it's doing is basically this. So what the way computer is reading is one of the two expressions, A less than B or 5, is one of them true?
Oh, okay. So the A is less than B evaluates to like false or 0, and the 5 evaluates to true or 1, and then the OR operator then evaluates those two together and puts 1 or true? Exactly.
So this one here in this case is 0, this one is 1, and this is always 1. So I mean, when in the eyes of the OR operator, this is 1, this is 5, but in the eyes of the OR operator, this is 1, right? So this will give 1. And so yes, and how do we get that in the which one to do first of the two? You go back to the precedence, and in the precedence, we said the logical OR comes the last. right? So you first do the less comparison and that you evaluate, and yeah. So you first do this one and then you do this one. Okay, so next question, and I'm going to start using the bonus points from now on. Okay, so the answer is the answer is A. So Connor, do you want to explain the answer? Or anybody else?
Yeah, I guess just because if the condition of A being 2, that'll be less than 3, so it meets the condition, and yeah, it just goes from there.
Right. So in this case, this one is 0, right? So in order for this thing to be true, then this has to be true. So now B is 3. It will be true if A is less than B. So if A is less than B, this one will be 1, and this will be true. So this is true if A is equal to 2, and no other option makes sense. So let's see, although I call Connor, but the first person to say A was Eddie, actually. No, it was not Eddie, it was Kinnan. So Kinnan gets a bonus point in my books here. I noted down. I made a 1 mark here. Okay, so moving forward. Yes, I'm assuming he had the same one. Next time we'll ask him to explain it too. Eddie, be ready. Next time we're going to ask you to explain it. Okay, switch statement. So A is equal to input get A. So that's how you input, basically that's a cin. Okay, this class ends at 10:45, I know, but we'll just go for a couple minutes and then we'll stop. So A is equal to input get A, switch A, case 2. So there's switch and there's case 2 will do this, case 3 will do this, otherwise it will do this. And so here in MATLAB, there is no break statement. Like we had the break statement in C++, we don't have any break statement. So it will only go into the case it is showing, and it will not show anything else. In C++, we had a break statement, which if you don't give a break statement, it would have continued to give the output of the rest of the cases. And that was, I think, Eric's question, Eric Schramm, when we were doing switch case in C++. And Eric, you were right that the switch case goes through all the remaining cases if it doesn't encounter a break statement. But MATLAB, it's different. There is no break statement. It only goes into the case it fits the value for. And yes. So we'll stop here. And we'll pick up from here.